Let's now take this problem number 18 of your textbook. This says that turn of radius 20 meter is banked for a vehicle going at a speed of 36 kilometers per hour. Shows that there is a turn on the road, and the turn radius is 20 meter, and the turn is banked. That means there is a banking you have seen in your textbook. The road is banked by an angle say theta. And it says the speed is 36 kilometers per hour. Speed is 30. I've earlier seen in many cases 36 kilometers per hour max. And also we know that for road banking, tan theta is equal to L by Rg. This is equal to V is 10. So 10 square by R, let us, R is 20 meter, it is given, and G is 10. So this is equal to, so tan theta is equal to half. This value we shall need to solve the remaining part of the problem. Then it says, the coefficient of static friction between the road and the tyre is 0.4. What are the possible speeds for a vehicle so that it neither slips down nor skids up? First of this kind of a problem, so you have to first understand the problem. There is a problem a little bit. Slipping down or skipping up or skidding up. It is actually like this. Suppose this is a road bank and the car lies in this direction, inclined with the vertical. And the horizontal component of the reaction force provides the centripetal force. Right? And there is always a frictional force. Frictional force also will have two components, horizontal and vertical, because the road is at an angle. Road is inclined to the horizontal. Now, there has to be a force balance in this case. Some of you who have driven a car on a banked road or a motorbike on a banked road, you must have experienced this. And in such case of banking, you will always find there is a speed limit sign, there is a speed sign given just before the banking. There is always a speed sign. Is written such and such kilometers per hour. Whenever you go to highway, you will find this. It means that the banking is designed for a certain velocity of the car. If you drive at a low velocity or very low velocity, there is a chance that the car will slide down the ramp. And if you drive too fast, there will be a chance that the car will skid upward the banking. So that is why it is very important in highways where you normally drive at a high speed to maintain the speed limit because the road is designed for that speed. Anyway, that was the story part. Now let's come to the actual part. Now, let us say you are driving too slow so that neither it slips down. Say, let us say we are considering slow speed phenomena. We are considering slow speed phenomena where tendency tendency to down, slip downward. In this case, what happens? In this case, now let us draw the force diagrams. In this case, actually, this is the angle theta, and let us say here is your car. Then what are the forces? Important. This is the force mg. And since there is a banking, the reaction force is always perpendicular to the road. This is the reaction force. The reaction force will have two components. One is r cos theta, r cos theta. It will have another component, r sin theta. Right? And also there will be a frictional force. Also, there will be a frictional force. And since it is trying to slip down, the frictional force will be upward in this direction. Also, there is a frictional force. What is this frictional force? This frictional force is mu into R. This frictional force also has two components. One is horizontal direction, which is mu R cos theta, and it will have a vertical component. Let us write it here. This is our sin theta. So we have all the forces written down. Then we have to only equate and horizontal forces to flip. That is not at all difficult. So we consider first the vertical direction. I write it for your understanding later on. Vertical, we first consider vertical direction. Vertical direction, we have r cos theta upward, r cos theta. There is another upward force which is equal to mu r sin theta. Sin theta. This will be equal to the vertically downward force mg. Now let us equate the horizontal forces. So horizontal forces, we take the horizontal forces. Horizontal forces, we have r sin theta towards left, r sin theta towards left, and also there is a centripetal force towards left, which is mv square by r. So r sin theta minus in the opposite direction mu r cos theta will be equal to mv square by r. Once you have written these force equations properly, then everything is done. Let us write down this equation as equation 1 and this equation as equation 2. Once you consider this, then what do we do? We do this way. Equation 2 divided by equation 1. Equation 2 divided by equation 1 gives you r sine theta minus mu r cos theta divided by equation 1 is r cos theta plus mu r mg square by r upon mg. This is equal to upon mg, which is equal to m and m gets cancelled, which is equal to v square by r, which is equal to v square by r. Right? Then, from here, what do we get? From here, we take v square by rg on the left-hand side because we have to find out v value. V square by rg is equal to, you do one thing, you divide both numerator and the denominator by both numerator and denominator by, so it is v square by rg, and mind it, here all the r's got cancelled. Here all the r's got cancelled. So you divide both numerator and denominator by cos theta. Shall we write divide? I write it here. It both numerator denominator by cos theta. What do you get? Sin theta by cos theta is equal to tan theta minus, that is mu r cos theta by cos theta is equal to mu divided by, this is equal to 1 plus mu sin theta by cos theta equal to tan theta. Now you just put the values of tan theta because we have earlier found that tan theta is equal to 0.5. That we have found. So just put the values of tan theta, 0.5 minus mu is given 0.4, 0.4 divided by 1 plus 0.5 into 0.4. Calculate this. This is equal to 1 by 12. From here we get v square is equal to 1 by 12 multiplied by rg equal to r is given 20 meter, g is 10 by 12. This is equal to upon 6. From here we get v is equal to 4.08 meter per second. If you convert this into kilometers per hour, it will be 14.7 kilometer per hour. So this is the lowest limit of the speed. Find it. What I was telling you earlier, the road was designed for 36 kilometers per hour. If you drive at 36 kilometers per hour, you are absolutely fine. But if you drive slow, then slowest you can drive at 14.7 kilometers per hour. If you drive even slower than this speed, your motorbike will try to slip down the slope. Then let us go to the part B. This was part A. Part B. When the bike or the vehicle skids and as such tends to, in that case, the same diagram will be applicable, but since the vehicle tries to skip upward, since the vehicle tries to skip upward, the frictional force will be down. Here, once again, this is mg, this is reaction R, this is R cos theta, this is R sin theta, R sin theta. Here, only difference is from the last case, the reaction, the frictional force is downward. Frictional force is downward, which is equal to mu r. This downward force has two components. One component is mu r sin theta. Another component is cos theta. And finally, there is a centripetal force, which is mg square by. Once again, like before, you solve the force equations. If you solve the vertical force, solve the vertical forces. If you consider the vertical forces, you find vertical is r cos theta, minus there is a downward force m mu r sin theta, mu r sin theta. This will be equal to remaining downward force mg. Let us say the equation 3. And horizontal forces, you will find r sin theta is on the left hand side, r sin theta on the left hand side. There is another left hand side force is mu r cos theta. Together will give the centripetal force mg squared by r. Say this is equation 4. Now, remaining part of solving this is exactly as the before. So I don't want to waste your time by doing it once again. If you exactly divide one equation by the other, then divide the trigonometric side by cos theta, it will become tan theta, and then value of tan theta is 0.5. If you do all these things, you will find V is equal to per hour. That means the road is designed for 36 kilometers per hour. If you are too busy and overspeed, you can go at the most at 54 kilometers per hour. or else your vehicle will skid up. And if you are too slow and lazy, you can drive at 14.7 kilometer per hour. If you are slower than this speed, your vehicle will try to slip down the slope. So this is the solution of this problem. We shall go to the next problem now.